For in each part of this problem, we're given quantities in terms of moles, and we're asked to convert that to number of particles. So when we're asked to convert between moles and number of particles, we need the conversion factor. 1 mole is equal to Avogadro's number, which is 6.022 times 10 to the 23rd. All right, part A, let's start with what we're given. 3.00 moles of tin. We need a conversion factor with moles on the bottom to cancel out what we're given and put the representative particle of tin as atoms. So that goes on the other side. So we need 3 significant figures. So it was 1.81 times 10 to the 24 atoms of tin are in 3 moles of tin. Next, let's do part B. Start with what you're given. 0.40 moles. Now, potassium chloride is an ionic compound. So to get the formula, we're going to use the charges to see what the ratio of it is between the cation and the anion. And so it's 1 to 1, so the formula is simply KCl. All right, we want to get rid of moles, so we need a conversion factor with moles on the bottom. And the representative unit, in this case, is the formula unit. So in 0.4 moles of potassium chloride, we have 2.41 times 10 to the 23rd formula units of potassium chloride. Part C. Sulfur dioxide is a molecular compound, so we're going to use the prefixes to determine the formula. It's SO2, because if there's no prefix on the first name, on these binary compounds, it just means there's one of them, and we don't write ones. Let's start with what we're given, 7.50 moles of sulfur dioxide. Set up our conversion factor to get rid of moles. And the representative unit for SO2 is the molecule. So we have 4.52 times 10 to the 24 molecules of sulfur dioxide in 7.5 moles of sulfur dioxide. Finally, part D, sodium iodide is another ionic compound, so let's use the charges of these ions to get the formula unit. They're going to cancel out, so it's NaI. So we start with what's given is 4.80 times 10 to the negative 3 moles of sodium iodide. And we want to get rid of moles and end up with representative particles. In this case is the formula unit. So we need 3 significant figures because all our numbers given had three significant figures. So 2.89 times 10 to the 21 formula units of sodium iodide are in what was given. So when you need to go between moles and number of representative particles, or really number of anything you're counting, you want to use the conversion factor, where 1 mole is equal to Avogadro's number.